Okay. Hello again, everybody. Thank you so much for joining me. We've got a little bit of background music to start off the night today. I hope everyone's enjoying their lovely Sunday morning or Sunday night. Thank you again so much for tuning in to another episode of Data with Danny. I really appreciate you guys and just spending your time with me to go through more of the machine learning and the data science and all this good stuff. So really, thank you so much. I think what we're going to do, we're going to wait for a few more people to come on, as always. But yeah, just hope you guys just chill and relax a little bit. Let me know how the music is. Love to hear some feedback on that as well. I'm not quite sure if it's too loud or anything, so we'll just see how it goes. But of course, I'm going to turn it down when we start going through the content. But yeah, I hope you guys have had a really great week. Thanks for tuning in. All right. Hey, Pratap, good to see you again. All right. Yeah, what we're going to do, we'll probably wait until 2 minutes 30 or so. But yeah, I hope you guys are excited for today's episode. Pete, thank you so much. Oh, Ayush, great to see you again, mate. Love it. Awesome. I hope I can share a lot of my learnings for today also. Yeah. Oh, Shadi, thank you so much for joining us. I'm Matabod. Thank you. Oh, awesome. It's great to see you guys again. I'm sorry I wasn't online last week. I was doing the hackathon stuff, so I was a bit too busy. I didn't want to try and overload myself too much. All right. Yeah, let's kick it off. I'm going to just turn off this music now. All right. Great. All right, let's get started. Thank you so much again for joining me tonight for the 6th episode of Data with Danny, Personalized Mentorship for Aspiring Data Professionals. Thank you again so much for spending your time, your precious weekend time with me, and I really hope that we can go through a ton of stuff today. All right, let's jump straight into it. So today's episode, what we're going to go through is, it's been much requested, but we're going to go through a few applied machine learning examples. What I'm going to do is probably cover most of my experiences actually within the marketing space. So I'm going to go through a few of my actual work projects that I've done within marketing and how it kind of matches up to some of the different problem spaces for machine learning application. But I'm also going to go through a few other industries also. So yeah, hopefully you can get a bit of a broader picture of where the machine learning is being used, and hopefully it sparks some of your imagination and some of your, oh, what have I done on the screen? Okay. Yeah, hopefully it sparks some of your imagination and really just gives you more ideas of where you can use the machine learning in your day-to-day role as well. After that, what I'm going to do is try and roll into this data mining project management, give you a bit of a flavor of how we actually manage some of these machine learning projects end to end. I'm going to go through one very specific process or standard process that is quite common in the industry as well. So yeah, it will give you a bit better of an idea of some of these terms that we use or that you see in a lot of these applications and job resumes and stuff. And the last one is, how do we approach certain coding projects now that we know some of these project management frameworks, as well as some of these machine learning examples? So hopefully that will tie it back into something that you guys can use and take away from today and try and think about how you can apply it to your portfolio projects that you're trying to code up when you're working on any work projects that have data in them as well. I think this is quite a nice way just to approach new problems within the data space. Okay, so let's jump straight into machine learning applications within the marketing space. So I'll just quickly run through these first 6 ones. So targeted advertising is always going to be a mainstay within this space. So If you think of anything to do with, the click prediction, if you're going to send emails and you're going to try and predict who's going to click on something. If you've ever seen on Facebook, maybe you get recommended some specific adverts at the top of your newsfeed. Most of them are going to be targeted as well to try and improve the engagement rate. So targeted advertising is a big space. And just as a primer as well, because a lot of the applications of machine learning currently, a lot of them are being done within the marketing analytics space. So I think this is why I wanted to focus on this area first, because a lot of the problems and the roles that are actually available are within marketing. So I think it's really great to kind of start there as a starting point to try and understand where the machine learning is being used in this space, and then branch out into the other areas where there are potentially less roles or less demand to use the machine learning at this current date. But yeah, machine learning is widely used within marketing for sure. And I think it's only going to continue growing as well. So it's definitely a good space to understand. So first, targeted advertising. We'll talk more about this as well. The next one I wanted to talk about was product recommendation. So think of these ones as, if you guys are in the US, if you're shopping at Walmart, I think that's the main one, or Trader Joe's or anything like that. In Australia, we've got Woolworths and Coles. They're the main supermarkets. But you can think of these as it might recommend you some products that you might purchase in your next shopping trip. This also extends to online. So it could be retailers. It could also be anything where you're trying to purchase something. So for example, Amazon has a very famous product recommendation system where kind of every time you put something into your cart, for example, it would maybe recommend you a few other products that other customers have also purchased, or some other products that are relevant to your shopping behavior. So I think, product recommendation is always used as well. Now, if we talk about customer segmentation, let's think of it in a retail shopping space. So maybe you can group your customer base into specific segments which have similar shopping behavior or demographics. So usually we can think of these as behavioral groups. And a lot of the segmentation is done to give probably marketing managers and business people a better understanding of who their customers are. I think in marketing, when we think of the data science and the machine learning within the marketing space, it's usually at a customer level. So when you think of all those different data points that you might receive based off shopping transactional behavior or customer viewing behavior on either a digital platform or a mobile app, we think of these usually in customer terms. So most of them would have some customer ID, some sort of timestamp, and what they did and in what order. So we can use this sort of behavior to really group down some of these customers. And then that really helps to explain certain phenomena. So oftentimes what we do is you might have, let's say you've got 1 million customers in your customer base. Of course, you can look at some of the statistics and some of the metrics at the whole population level, but it'll be much more precise if you could drill down into specific segments and really understand behavior of specific groups of customers that you're interested in. A lot of the segments that we see in marketing space would generally be based on things like spend. So how much money have they spent with you? How many times have they visited your page? How many times do they log in? This is probably one of the areas where a lot of marketing managers would love to know more about certain groups, so then they can devise different strategies and different business plans to really hone in on that customer group. So this is where we can use a lot of machine learning. Specifically, clustering is very great for customer segmentation. But in general, for these customer segmentation problems, I think we can use unsupervised learning here. So that falls within clustering, is probably the main one for unsupervised. You can do other stuff like probably I think collaborative filtering is sort of semi-supervised, but you can also do that as well. But in general, customer segmentation, you want to try and condense the customer data into a specific space and then try and group them together so then you can get better clarity of which groups of customers are in there. Okay, let's go on to the social network analysis as well. So I've kind of cramped myself here with all this space, but I'll just go over here. So if you think of social network analysis, the first thing that usually comes to mind is Facebook. Facebook, LinkedIn, they're very famous for having social graph networks where they kind of link all their customers or all of their users into specific graph type data structures where you usually have what the graph usually has a customer at a node. So let's say this is customer 1. And this customer might be connected to another customer, customer 2. This customer could also be a user as well. And there could be a relationship between customer 1 and customer 2. And let's just say they're connections, for example. So at this stage, you can also then start expanding it out to many, many customers and many, many different types of relationships. And then you can do a lot of unique analysis, specifically network analysis, to try and figure out which groups of customers are similar, how far apart are they, what sort of content do they look at. And in each of these nodes, you can also store quite a lot of data in key value pairs also. So you can really structure the data in a really neat way, so then you can use the relationships as a way to break out some of these customer groups and get a bit more intelligence from them. So social network analysis is really interesting. It's an area that I'd love to get more experience in. In the banking world, we used it a little bit for money laundering. So you can imagine where there's customer 1 and customer 2. The connection might be customer 1 has sent money to customer 2. And then you can kind of try and see where all the money is flowing. So if you see some dodgy customer, for example, who has a lot of money coming in, but no money coming out, it's a good way to kind of track suspicious customers. And then we can do more ad hoc analysis to then find out what's up with this customer. What have they done? Are they dodgy? And that's one of the applications here as well. So I think social network analysis is very interesting, very good for the new social media world as well. So when you have all these customers with connections, with friends, with followers, you can really see what groups of followers are doing and what their preferences are. So I think that's super interesting. And if we also then move on to chatbots and sentiment analysis, this one is like your very typical in marketing. What we like to do for chatbots is usually, let's say you land on someone's web page, their shopping page, online shopping. What you'd have is maybe a box just pops up on the bottom right-hand corner, and then you've got this bot that's asking you, oh, hi, Danny, what would you like to buy today? Or something like that. And then you can kind of type some text back, and maybe it should have some machine learning guts inside it to be smart about how it should respond to some of your natural language. But more often than not, what we see in industry at the moment is most of it is hard-coded rules. There's usually if-else type flows or statements that kind of go, if Danny asks about credit cards, we kind of funnel him through this specific channel of questions and answers, and then they might do some very simple text mining to just go, oh, this question that Danny's asking is very related to question and answer 1 when he's asking about his credit card and how much more money does he have available for him to spend, for example. So I think what we want to see within this chatbot space is to have more and more smarts from the machine learning components with all the new deep learning innovations, like you must have heard of GPT-3 and all these other new deep learning algorithms that are coming out that are very, very smart. They can process natural language really well. Sometimes some people are calling it scarily very good, to the point where it can start generating its own code. I think it's very cool and something that we should start looking into. But for now, I think chatbots in industry, they're usually quite rudimentary. And when we think of the sentiment analysis, So one of the examples where I was using sentiment analysis was when we were looking at customer complaints. And this kind of happens both within the banking space as well as the retail space as well. So within banking, maybe we've launched some sort of digital app experience or whatever. And at the end, when someone exits out of that experience, maybe we pop up a survey, might have a few questions, and then right at the end, it might have a free text field where it can kind of ask people, how was your experience? Is there anything that we can do about it? Was it good or bad? And then we would just use very simple sentiment analysis to kind of just try and pick up some of the words which were related to a good sentiment versus a bad sentiment, and kind of predict out what was the overall customer sentiment for this specific response. But of course, there's a lot of messy data in there. So it was quite a challenge just to clean out some of the text that customers were putting in. And then there was another question of how do you train the algorithm to actually pick out what is good versus bad as well. So I think that was a pretty interesting project. And I think it's exactly the same thing for complaints as well. So usually when customers complain, they're usually on a scale of neutral to angry to very, very angry. So I think one of the examples where we built something was to try and understand what the sentiment was of a specific complaint. And if it was really, really bad, we would try and flag that customer, and then someone would actually go out and call them, for example, or reach out to them directly to try and get more feedback and try and help them. So I think, yeah, sentiment analysis is pretty useful. You also see it a lot in some of the examples that you see in the coding projects is usually the tweet sentiment analysis. So you might have some Twitter tweets come out and some of the data comes through, and a lot of people try and predict what the sentiment is for some of these tweets. I think it's quite an interesting project, definitely something that everyone can look into as well. But yeah, that's just another place that we generally use it too. Okay, before I go into the multi-channel attribution, I've got a question from Rajan. Question out of curiosity, where do we get data for social network analysis? I mean, is it available online, or are there APIs, or are there requests to be made? Okay. I personally haven't asked for my data from a LinkedIn or a Facebook or Instagram or anything, but in general, when we think of the social network analysis, when we're working, you can kind of build these graph databases or graph data sets out of what looks like quite traditional row and column tabular data sets also. Part of the transformation of turning that normalized data into a graph format is part of the challenge of when we work in this social network analysis area. It's probably, I'm not sure if I can draw it out here too well, but usually you'd have, like, I don't know, customer. If we go back to this customer 1 and the customer 2 and their connections, usually you might have a table that just says connections, for example. And within this table, you might have a customer ID. And let's say that's like the customer ID where we want to track all of their connections. And then you might have another column where it's connection ID, for example. So maybe in the customer ID on the left, you might have customer ID 1, and they've got customer ID 2 as their only connection, and vice versa as well. So maybe you have customer 2 on the left, and they also have customer 1 as a connection as well. Sorry, it's gone off the screen. But part of the transformation into the graph format would be essentially to take this information to say, okay, for each of customer 1, let's try and find who they're connected to within this one. And then you can kind of build out that sort of relationship at a very low level. Maybe you'd want to join other tables as well to try and find out what information there is about customer 1. So maybe you might have their age, demographics, all of that sort of stuff also. But I think it's more of an area which personally I need to work on it a little bit deeper to really explain in very in-depth knowledge to you guys for next time. But it's a good way to represent the data. So then you can kind of get this relationship style without having to go through joining a ton of different tables just to get the different relationships also. So it's more around it's a data structure sort of problem. I think it's very interesting. And what we're seeing now is a lot of the analysis that we do in industry, a lot of it is moving towards graph databases, because now we're seeing a lot of these networks and a lot of the relationships can be abstracted away into these simple relationships. And we can use them in a more efficient way than if we had to write a ton of SQL and join all these different tables in the database. So it's more of like a mindset shift of moving away from regular columns and rows to more going to nodes, vertices, and edges, and more of the key value pairs within that data to represent more of what's going on from a relationship point of view. So it's very interesting, and I highly recommend to read further into it. But yeah, hopefully I'll have some time to go deeper in future. Okay, let's talk about the multi-channel attribution also. So I'm not sure if you guys have worked in marketing before, but one of the holy grail of digital marketing or targeted marketing or advertising in that sense is usually people want to see the right message at the right time and at the right channel. I think there's more, but in general, it's usually, can you send out whatever advertising or any sort of intervention to a customer with the right words and the right offer, maybe if they've got a targeted offer, at the right time and also on the right channel. So whether it's mobile versus, let's say mobile versus an email versus if they're browsing the website and you pop up some ad that pops up directly onto the page, all of these are different channels when we think of it from a marketing intervention point of view. So what we think about for the multi-channel attribution is usually when you think of marketing, they get given a budget for certain campaigns. So a certain campaign might have, let's say, $100,000. So $100,000. And usually when we think of marketing for the channels and the interventions, each one of those contacts usually cost money. So if you think of, let's say, a Facebook ad, as well as an SMS. I know SMS is a bit outdated these days, but people still use SMS for their marketing as well. And maybe an email, as well as, let's say, there's some pop-up when people visit their website. Okay, sorry, I was writing off the page. So all of these different channels usually have a cost attributed to them. And also the cost is usually at a per contact level. So a lot of the multi-channel attribution is trying to figure out which customers did we contact in which channels, and then try to allocate specific uplift or conversions to a specific channel. So when we think of multi-channel attribution, it's all about, of course, it's all about the money, but it's all about where should we spend the money in future to optimize the conversion rates or the uplift. And when we think of multi-channel attribution, we can kind of use conversion as a success metric, and all of the different channels that we might have contacted different customers for a certain campaign as features. And you can try and figure out where some of those features are more weighted compared to other customers. But in general, when we think of multi-channel attribution, it's about using the machine learning to build a model of if we contacted certain customers on certain channels, how likely are they going to convert? And then you use this information to try and roll it back up to how much conversions, the real conversions that you actually had, and conversions usually lead to sales as well. So it's sort of, it's a bit roundabout, and in all honesty, all the models that we build within the space for the marketing, they're not going to be super accurate. There's a lot of noise when you think of marketing. So you might have contacted someone with a specific offer, but let's say that they wanted to buy the thing that you offered them anyway. How do you really calculate how much impact your intervention had? So a lot of it is to do with marketing is still a very, let's call it a fuzzy space. Machine learning is still going to be used in there, but there's going to be much more of a focus on how to design some of these experiments that use the machine learning to actually figure out how much uplift or how much more value is your machine learning adding to the existing thing that is already happening within that marketing space. So when we think of that, I'm going to go back here to the targeted advertising. Usually when we think of the targeted advertising, let's just say we're going to build a model of a very simple whether someone purchases or not. So you might have your final classifier might give you a probability of purchasing. So when you have this probability from your model, then you have to think about, okay, if I predict the probability of someone purchasing something to be, I don't know, let's say 70%, should I send them an offer if they're so likely to purchase something in the first place? What do I do with customers who are not likely to purchase? Should I actually send them an offer to then try and increase their probability of purchasing? So all of these ones, you can try and get the data from historic data to try and build some models, which we call uplift models. But essentially they're binary classification models where you have either someone has been sent an offer and they purchased, or they were sent an offer and they didn't purchase. So a lot of it comes from experience working in the space to actually try and figure out, okay, what data do I have? How am I going to use this to try and build the model? And then once I have the model, how do I apply it in a way where I can design an experiment and figure out how much value I'm getting from what I've done? And that's probably a lot of the machine learning that's being done right now. We need to focus much more on how we experiment with the models, because a lot of the time what we're seeing is people are really good at building machine learning models, but not a lot of people are really good at using those machine learning models in a business problem. And this is where I really want to focus in on and help you guys try and get a bit more exposure to this problem and really identify some of the issues and where you should be more aware. Okay, so this is most of the machine learning applications within marketing space. We're going to move on and talk about some other industries where machine learning is being used as well. So in this space, I'm pretty much just going to ad lib and give you a few different scenarios where we could use machine learning within each of these scenarios. So in financial markets, of course, we see the quants and the quantitative analysts, the hedge funds, the traders. Of course, they're using some machine learning to try and get an edge on the market and really pick out which stocks they should buy, sell, the different prices that they should buy and sell at. Is the stock price going to go up? Is it going to go down? By how far? All of these questions, definitely you can use machine learning to answer them. The challenge in the financial markets is that the historic data doesn't always look like what it's going to be in the future. So a lot of the problems within financial markets, it's more around, does your historical data match the data that you want to make a prediction for? And then also within the financial markets, so of course you're going to have things like stock price prediction. Maybe you'll have other things such as, oftentimes what I've seen within the hedge fund world is also, a lot of the times it's very difficult to predict the actual price, but it's much easier to predict some of the price movement. So they've got all these different terminology where, let's say a stock price goes up a little bit, and at the end of the day, it goes all the way down because people are trying to sell off just so they can come back in the next morning and buy back at a lower price. There's all these different sorts of scenarios or macro level behaviors that people can try and codify into logic. And then you can kind of build that as a machine learning label for a binary classifier. And then you can really use that to predict whether that specific behavior is going to happen within a certain time frame. So a lot of the time in financial markets, it's more difficult to predict the whole stock price as a whole, But if you can try and break down some of the behaviors of the market that can change the stock price, it's much easier to kind of build those separate models. And then you can kind of lump all that data together, and then you build something which is closer to the stock price final model. But of course, in financial markets, if it was so easy to do that, then everyone would be making a lot of money, and then no one would be making any money because everyone is also using the machine learning. So I think it's definitely a very fun and interesting space. I know in financial markets, they also use quite a lot of Twitter data. So when you think of sentiment, so if, let's say, Elon Musk's write something that Tesla is doing awesome this year, they just got funding for whatever, blah, blah, maybe their stock price will go up purely because of speculation, or maybe it's going to go down. And all of these things, it doesn't have to be Elon Musk. It could be anyone talking about certain big investors or something. I'm sure there's some laws against it, like some insider trading or whatever that Elon probably got fined for. But yeah, things like that. Some of the quants and some of the machine learning practitioners within the financial market space, they want to try and pick up on some of that market sentiment and see if there's any corresponding movement with the market prices due to some of this behavior. So we can think of sentiment analysis as being used heavily in this space also. Another thing in financial markets that people might like to look into is also text mining. So let's say there's reporting season. So in different times of the year, a lot of these companies that are in the in the S&P 500 or Fortune 500 or whatever, they'll all release their reports, their financial reports at certain times of the year. So traditionally, you'd have your quants and your hedge fund analysts kind of looking through all of these reports manually. These days, you can kind of parse in that data and analyze it using machine learning algorithms for text mining. Maybe you can also scrape some of these guys to try and find out some of those metrics that are in certain tables that are baked into the report also. So I think there's a lot of automation that's being used, a lot of machine learning automation within this space for financial markets to try and get information faster. So then the people who need to make the decisions can make the decisions faster. But you can also think of this as a lot of automation within there. Another space which is really cool within financial markets is what we're seeing is some companies are starting to use reinforcement learning for some of their autonomous trading. I think it's really cool. I'd love to try and build something like that where, so if you think of reinforcement learning, essentially you have an action space, and you probably have contextual data as well. So usually when we think of the action space, let's say it's a very simple trading algorithm that you want to build, and you're essentially just going to go, you either buy, hold, or sell. And what you can do is try and train the model to try and figure out, okay, with certain stocks at certain points in time, what should I do to try and maximize some sort of profit or some sort of some metric or a rule. We usually call it like a loss function or a reward function. But in this case, specific to financial markets, you could have something where you want to maximize your profit, but you also want to minimize your loss as well. So there's certain different criterias that you can use within the financial management space, which you can use directly as a loss function within the machine learning algorithm. And then you can kind of play it over historical data to try and train these algorithms and optimize them within the reinforcement learning phase. So I think it's really cool, and it's definitely an area where there's a ton of research going into it. I suspect that all the big hedge funds and investment banks are putting a lot of money and hiring a ton of really smart people to work in this space. But yeah, it's really cool. Either people have already solved it and they're not telling anyone, so they can make more money with their algorithms, or no one has solved it yet because it's a really hard problem and the historical data doesn't really match the data that they want to predict for. So it's a very cool space. I think it's some data scientists really think of financial markets as the holy grail role where people want to be very close to the money. So if your model goes really well, maybe there's some reimbursement or some sort of compensation where it says if your model generates X amount of profit, you get 30% of it or something like that. So I think financial markets is great for the data scientists and the machine learning practitioners who want to be really close to the money, where all of your models, if they're wrong, you might lose money. So if you like the rush, the adrenaline rush, and that feeling of being really responsible for what you're delivering, maybe you should look into financial markets. Okay, now let's talk about another one. Oh, before we do that, I'm just going to scan through some of these. These questions. I'll just go with this one. So, Suraj, recently I've seen machine learning in sports industry. Yep. So one of my good friends, Mr. Ken G, on YouTube as well. Mr. Sports Data Science YouTuber is a real boss. He talks a ton about using the machine learning in sport as well. He specifically used it to, he tracked his own data for his own golf practice. So he used to be like a pro golfer, and he was tracking a lot of his data and using that to analyze his own performance to see where he can optimize some of his practice or some of his technique and different things like that. So definitely can be used. I know there's probably, you can jump onto his channel and just try and find out more because he's got in-depth experience in there. But yeah, definitely machine learning is used in sports. There's a very famous movie as well of I forgot the name of it, but it's like some baseball coach hires, or he brings on all the players that have really good statistical strike rates for their batting or their pitching. But those players were very undervalued, but their team did really well purely based off the statistics. So I think someone can probably comment in the thing to say what movie that was. But yeah, there's a few different examples where very simple analysis works within the sports industry. Yep, everyone is saying Moneyball. Thanks, guys. Thanks, Kevin, and thanks, Justin. But I think, definitely machine learning is used in sports. I think they're using it more for I think people are putting trackers on people and sensors on players when they run around the football pitch, for example, and they can tune that to try and optimize for, Danny, the striker, has ran 10 miles or something in this game. We need to really up his recovery needs for this week or something. But a lot of that, I'm not sure if they're using a lot of machine learning or whether they're using more just analytics within that space. Because there's in these new areas where there was never really any data before. What we're going to see is a lot of quick wins just come from pure, very simple insights and analytics that deliver all the valuable parts before we even see any of the machine learning. Too often we see a lot of companies, they dive straight into the machine learning, but they leave so much money on the table because they haven't done the initial foundational work to just clean their data, analyze the existing state of things, and they just jump straight into some of the machine learning algorithms. So it's something definitely to watch out for as well for other industries. Okay, so I've done almost 40 minutes talking about just marketing and financial markets, which is pretty cool. So I'll have to try and rush through some of these ones a bit quicker. Machinery failure, I think that was just a very unique example that I've come across before. I think I heard Mr. Ben Taylor was talking about one of his models that he built for that and that went into production. So I think for machinery failure, it's pretty interesting because in Ben's example, he was talking about more that, so he built a model for a certain piece of machinery, and it was going to predict whether it was going to break or not, break down within the next half an hour or whatever, some short amount of time, and it was going to be a catastrophic failure. So in his example, he said that his model was very good. He trained it very well. But when it came to actually using the model, so it gave an alert to someone who had to wake up in the middle of the night and fix the machine or whatever it was. But the people, the business process, the people who were using and actioning that advice and the intelligence, they actually didn't believe the algorithm. So I think it's one of those examples of the machine learning. It's like one of those negative examples where you kind of, in this case, it's you really need explainable models in certain situations to really get the business buy-in. I think in his example, the model detected that the machinery was going to break down. The guy ignored it because he didn't think that it was it was like a false positive. And then what happened was the machine broke down. And then who do you blame for that sort of thing? Do you blame the person for not reacting based off the model, the machine learning insights? Or do you blame the developer who didn't explain what the model was doing and give the end user more insights on why it was making this prediction in the first place? So this one is a very interesting example. So I thought I might as well share with you guys. Okay. Another area where machine learning is being used is in banking and insurance. So traditionally in banking, you might have seen if you're applying for a credit card or if you're trying to apply for a home loan or a personal loan, you might get either you get accepted or you get rejected. In the past, they would be based off very simple models, maybe a regression, logistic regression, or it would be something, maybe even if-else rules. But these days, what we're seeing is a lot more moving towards maybe boosted trees or decision trees. Decision trees are quite basic as well, random forests, but they're using more traditional machine learning algorithms now, maybe some deep learning to capture more information and be able to provide very explainable reasons for why customers are not being eligible for a loan or a credit card, for example. So, and in the insurance space, probably I see Kevin is here as well. So Kevin, I think he works within the risk management area within the insurance. So these days, I think insurance traditionally, I did my bachelor's in actuarial studies, so I know a bit more about the insurance industry. But what we want to do is try and build some models to figure out how much money we want to hold, or as a bank, for example, or sometimes in insurance, you want to predict which customers are going to have a car crash, which customers are going to pass away for their life insurance benefits and different things like that. A lot of the times what we're seeing now is a lot of those traditional actuarial models are moving towards more of a machine learning based prediction. So I think that's a really cool space as well. When we think of, so I'm moving on to the agriculture and the forecasting. So I had a really cool chat with one of the guys in Australia who's building sort of like a data platform that captures a lot of satellite imaging, energy prices, water flow rates, and all these different things which are specifically used for agriculture and maybe for social planning and environmental planning for the government. So I think it's a really cool space. It's something that I'd love to try and help out, because I think helping the environment is quite important. And farming is also a very large industry in Australia, and whatever we can do to help our farmers should be a good thing as well. So I know a few friends who are really passionate about, they might have come from a farming family and they want to try and use their skills to help and give back to some of that industry as well. So what we've seen is some of the more left field examples would be, let's say you get all these satellite images of different paddocks or grassy fields, and as the satellite flies by and takes hundreds of thousands of photos, you can kind of use these to identify maybe different cows or different animals that are in the paddock, and use that to count to make sure that all your animals are where you want them to be. Maybe we also see some of the data that comes through would be the water levels. So if there's been rainfall and certain water levels in the dam that holds all the water, if it reaches up to a certain point, there'll be some overflow, or maybe it flows down the river a bit easier. And that might actually help farmers to time when they water their crops. So it's a little bit more abstract. You need a bit more farming knowledge to really work in that space. But I think it's really interesting where you can really have a lot of impact. So I think what we're seeing now is, like, a lot of the time people will be predicting the rainfall, which is very useful as well. And then whether people want to water their plants. We're also seeing, I read an example when I was researching for this session where people are starting to do more, like this is more within the medical space, but they're trying to do more genetic hacking of plants to make them grow a bit faster. All of those like GMO plants or whatever, people are trying to do that to improve the yield, improve the success rate, reduce the failure rate, and all of these things, which is pretty cool. But it depends whether you want to be organic or not. So I don't know, it's up to you really. But yeah, agriculture is another space where there's a lot of machine learning happening as well. I think it's a great area to get into because it's probably really undeveloped, and it's another one of those areas where there just wasn't a lot of data before. So it's probably one of those massive growth areas that we'll see coming up soon as well. Okay, so medical diagnosis and research. I'm sure you guys have seen all those image recognition of cancer diagnosis or COVID diagnosis based off x-rays, lung x-rays, and different things like that. That's definitely one of those applications. I actually worked with one of my close friends from university who was doing a medical degree, and I used some of the text. It was like the description of someone's symptoms, and then he also had classifications of what their actual their issue was or what their disease was. So it was pretty interesting. I just did some very simple text mining on some of those descriptions, and I kind of filled out the rest of his data set for him. And then I kind of ranked some of those predictions to give him the ones which were kind of less powerful. So then he can really guide them and build a better model with this kind of semi-supervised, repetitive learning process where, so what I do is get him to read out the first 1,000 or something. He would say, okay, this one is disease 1, disease 2, disease 3, or whatever for the first 1,000. I'd build a model on those 1,000 examples that he's labeled for me, predict for the rest of the data set. Let's say he's got 500,000 different records. Then we can kind of sort through the model and try and figure out where the model went wrong. And then we can go back and repeat that process so we can continue building a really strong model. So I thought that was really interesting. And I did that sort of work like almost 5 years ago when I was just starting off. So it was one of the projects that really opened my eyes to, oh, wow, if we just use very simple machine learning techniques, we can really get a lot of stuff done and help the researchers and help some of these different industries just move forward with using new data techniques. And that was really cool for me. Also within the medical research space, you might have heard of people doing genome sequencing or DNA sequences where they're trying to predict what's the next sequence or which genome relates to a certain species or different things like that. Personally, I don't have too much experience in it. I'm hoping that I'll try and find someone in my network who does have more experience within the medical research area, because I think it's so cool. It's such an interesting space. And I know a lot of people really want to use their skills to work in that area to try and move forward like medicine in general. So yeah, definitely it's on my to-do list to try and find someone with that expertise so we can really pick their brains on how they use machine learning within the medical space also. And of course, you must have heard about autonomous vehicles, Mr. Elon with his Teslas, Google and their self-driving cars. I think Elon also has something where he's got like, within the OpenAI gym, they have this, I think it was like a pole or something. And then you have to try and keep the pole stable. And it's supposed to be one of the autonomous components of the Falcon rocket when they're landing it on the actual launch pad and the landing pad, which is super cool. And it just blows my mind because it's like, we're thinking of very simple, like we go from machine learning as if else, very simple sort of rules-based stuff to all the way where they're using it to land rockets. And they're probably using a lot of deep learning and complex models and a lot of things within there, which is just really cool. Like, if anything, like, I'm not sure if I've gone through some of these applications in too much depth, but it kind of shows you the breadth of where the machine learning can be used. And it's really just going to take over a lot of industries that are existing. I think it would be like
almost any industry where there's some sort of repetitive or anything where there's some sort of prediction that has to be made or some sort of intelligence where it can help certain practitioners or experts within the field kind of process a lot of information faster and give them more insights. Yeah, for sure, that's where machine learning should be used. Whether it's going to replace a lot of those experts, I'm not too sure. I'd love to say that on one hand, some people really want like, oh, we should automate everything because there's less error and there's more efficiency, and people can do what they want to do instead of having to work their jobs. But I like to think of more the machine learning will help us really move forward and kind of automate some of the boring stuff so then we can focus on more of the higher level problems that we should be solving. So that's my own personal view on the machine learning, but I think a lot of others share some similar views as well. Okay, just reading through some of the comments. Oh, thank you so much. Oh, whoop. I clicked on one, but it gave me another. Thank you, Ogawa, for your support. I'm going to try and click on this. All right, so Gaith, I hope I said your name correctly. But yeah, I would really love to talk with you guys after, so I'll check my LinkedIn for a message for sure. But yeah, I think Sheldon really wants to hear about brain diseases and disorders too. I would love to know too as well. I think it's such an interesting space. Like for me, I haven't worked in that area, but I'd really love to see where I can use my skills because I think it's just so cool. Okay, so moving on from these applications, I'm going to talk about how we manage some of these larger projects. And in particular, what I've come across is something that is used quite widely across the industry. It's called the CRISP DM, which stands for Cross Industry Standard Process for Data Mining. But you might have also seen it I know in actuarial studies, they call it a control cycle, or it's always some sort of circular sort of concept. But in essence, you essentially have, I'm just going to zoom in here. There's different phases. So you've got there's business understanding, data understanding. There's then some preparation, some modeling. Something I want to point out here is this modeling. It's not always machine learning predictive modeling. It could also be data modeling. So think of databases or data pipelines or different things where you want to prepare the data so then it's actually useful for people. That can also be considered modeling in this sense. Then after you do the modeling, maybe you do some machine learning as well. Then it goes to this evaluation phase where you really figure out whether the thing that you've modeled or the thing that you've prepared, whether it's going to be useful. And it's really like evaluating an experiment or a prototype to see if it's useful. And of course, you see like there's going to be a link back to the business understanding. So if you really need a strong business understanding to know whether the thing that you've generated is useful. And I think it goes back and forth, and then it usually they do this cycle a few times before they really land on the thing that they want to use. Then once they finalize it, then they'll go straight into deployment stage. And deployment in let's say the database format, it could be scheduling some scripts or deploying a package of scripts that get ran regularly. In machine learning, it could be you deploy the final model and it gets used in production. But a lot of the problems that we solve, we don't traditionally actually refer to this as the CRISP DM cycle or whatever. We kind of like we work within this circular framework, but the majority of the time we'll spend actually here. So you know how there's a lot of people saying, oh, machine learning and data science, 90% of the time we do is data cleaning, data cleansing, or whatever it is, data munging. I'd almost challenge that, and I'd say we spend much more time trying to understand what the data is before we even do any cleaning. It's a very common pitfall to just kind of jump right in and clean, assuming that you know everything about the data. A lot of the time, what I like to do with my projects when I'm working on a new one is to really talk with some of those SMEs, the people in the business who've been around and understand the processes that actually generate the data. I think that's super, super important, because let's say you assume something about a certain data point or data set and how it's generated, and maybe it's just totally different, and that might change your entire project. All of these things are very common pitfalls, and you see them very often. So, and most of the time, if you don't catch those things early on within this space, usually by the time you go through one iteration and then you get the business to evaluate what you've built, the business will come back to you and tell you, oh, look, Danny, I really like the work that you've done, but it's just not useful. Like, it's missing the point. So I think when we work on any data project, the most important thing is to really capture the scope and what the business really wants. To do that, of course, you have to be an effective communicator, ask the right questions, try and absorb as much knowledge as possible. So it's definitely within this space, it's more of a consulting skill set as opposed to a raw analytical coding technical skill set. So of course, having that blend where you can really talk to others, understand what's going on, link that to what the data looks like, and then formulate a plan for how you actually clean the data, how you build the models, how you present those findings back to the business is very, very important. And I think it's an area which is not really taught. I know within a lot of the online courses, they're not really taught. I'm not sure about university degrees. I never really did a master's in data science or anything like that, so I can't comment too much. But I really think that there's something here where a lot of people should focus more on, and it's very difficult to learn because it's more of a soft skill than an actual technical skill. So yeah, definitely people need to spend a bit more time on trying to solve this problem. But in a nutshell, we always think of data projects in this sort of circular sense. So always understand the business, then figure out your data, prepare and clean the data for whatever processes that you need to do downstream. So this could be a machine learning model, or maybe it's a data model for your databases and your SQL databases or different things like that. Then you would go into evaluation phase where you would probably do some sort of presentation for the business, and you get their feedback, and then you do this loop again until you jump onto the final thing, and then you move into this deployment area where it gets built and scheduled. All right. So within this process of the data projects, we can think of the different types of projects within the data space in general. So I don't think this is a hard and fast rule. It's not very strict. This is just some of these 6 types of projects are the ones which I've encountered in my career. And I think they're quite split out in that sense. So I'll just run through them as well. So the first one that I've put down here. Oh, before I move on to these different types of data projects, I'll just try and answer this comment here. So Agaro is asking, do you agree with deployment being the last final step of data projects? So this one's quite interesting, actually. Traditionally, what would happen is the deployment cycle would be really, really long. So once you have the final thing and you deploy it, usually you wouldn't touch it. Like that's the end. If you touch it, it's like another few $100,000 or $1 million project, and the funding usually doesn't happen because you already spent so much effort to put that first thing into production. So what we're seeing now is because the development cycle and the production cycle and the deployments are taking much less time, and this is the trend moving forward as well, especially for machine learning. What we're seeing now is there's more of like almost a software component of it, where in traditional software development, you'd have continuous integration, continuous development, and within the machine learning space, we also have continuous evaluation. So if you've got a model and you want to evaluate whether your model is still performing at the right accuracy level or precision score or precision or recall or different metrics, you actually have all these ways to track that model and the performance. And if something goes wrong, you should kick off other processes that maybe it retrains it, maybe it flags the data science team, and then the data science team would go back in and try and figure out what went wrong with their model. And that process happens in the background, but once they're ready to deploy the new thing, they should be able to almost flip it into production very quickly. I think this is more within the ML ops space. I know the question was more around data projects in general, but definitely machine learning, that cadence should be faster and faster. For data visualizations and dashboarding, you also get the same thing as well. So the tools are becoming more mature, where you would usually deploy something that happens, deploy something which is useful and the business sees it and they're like, oh, this is great. Something changes, maybe they want a new metric in there, maybe they don't like a certain visualization. The analyst or the developer should be able to go into the code base, make the change, stage the change, and then the deployment process happens straight after once the code comes in. And this is more around the software development cycle. And I think this is where a lot of the data projects is moving towards. So I think this is why I'm really passionate about sharing more awareness of where we're moving in the industry and highlighting some of the skills that we should focus more of our time on as well. Okay, so I hope that answered the question. But in a nutshell, deployment is the last step, but it shouldn't always be the final step. So it's once you deploy the thing, you should always be looking on how can you improve it, how can you make it better, and all of these things should happen in code, and then all the integrations should be seamless as well. Okay, so let's talk about the different types of data projects. As I was saying before, these are not very prescriptive, but it's more just my understanding of the different projects that I've worked on. So the first one that I thought was really interesting was the foundational aspect. So when we think of foundational, it's usually around data assets, data pipelines, data engineering, getting the raw data into something that looks familiar to the people who are going to use it downstream. For example, let's say you've got all this messy JSON data that comes from a digital website, for example. Traditionally, you wouldn't want your data analyst to go and query JSON XPaths, for example. So what you'd get is probably the data engineers would do some massaging of the JSON. Maybe they do some schema validation to make sure all the data types are correct, automate and deploy that data processing pipeline, and then deploy the thing onto, I don't know, the cloud or on-premise or a Hadoop cluster somewhere. And then when the data comes in, all the processes happen. Maybe it happens real time. Maybe it happens batch every day. And then it just lands in this database that then the data scientist can consume, where it just looks like regular columns and rows in a traditional database format. So I think of foundational data projects as purely data engineering ones. Of course, you can also add in more components of you can also build foundational projects where you're building a framework for machine learning projects as well. So there's a broad range, but when I think of foundational data projects, data or machine learning projects, it's usually around pipelines, automated pipelines. So let's go pipelines and frameworks. So for example, another example would be in one of my recent projects, we built so SQL is used very heavily, not only in traditional databases, but also in a big data land. So you're thinking Spark SQL or BigQuery SQL or different things like that. So we helped build some sort of framework where the data scientists or the data analysts can write normal SQL, but what we'll do is lift that SQL and we'll run it within a Spark environment to get more scale. Or we use that to then abstract out, we can run this in Spark, or we can run this in BigQuery, or we can run this in Redshift. So I think some of these are more foundational in that sense. Okay. The next type of data project that I've put down here is exploratory. So you can imagine, let's say you're the first data scientist or the first data person that arrives in a company, and they throw at you 10 let's say 10 different spreadsheets that they've been collecting for the last few months. And then you have to figure out what's going on, where has the data come from, what are the processes, and really try and figure out what is going on and explore. So I think of these, that's one example. Another one could be like, in general, most of these exploration things are there's new data. So if there's a new data set, or there's a data set that no one's used before, maybe it's a new data set that's new to your team. So if you're working in a large organization, there might be lots of different silos. Maybe you're working in the digital space and you get given a transactional data set that you've never seen before. You have to do some exploration of what's in there, trying to figure out exactly what the fields mean, how do they get generated, what is the business translation of certain fields, when does the data set get built, when does it get processed, who was it built for. All of these questions should be answered, not just for an exploratory project, but usually for all the projects. But more often than not, when I think of these, when the times I was sent in to try and figure out what was going on, I thought of those projects as more like an exploration phase. Oh, sorry, bumped on the mic. Okay. So whenever there's new stuff going on, we think of exploration. The next one is insights. So a lot of the time for data analytics, we often get told, okay, here's the data. Tell me something about it. Tell me what's useful. Tell me what I should be doing. What decisions should I be making based off this data? What insights do you have? So one of the first problems that I had to solve when I was working in a data analytics role was which brand of ice cream was most popular in summer. So it was very prescriptive in that sense, but you can imagine for the insights, sometimes it can also be insights with new data sets as well. So you kind of get this blending between the exploratory data projects and the insights data projects as well. But insights, usually we think of it more as like, how will the business use your outputs from your data? So this could be, maybe it's a data storytelling, maybe it's a key insight, like 44% of customers are unhappy, or different things like that, where the business can actually make a decision and action it. So a lot of the time what you'll hear is actionable insights. You see this in like a lot of job ads and different things as well. But it's really true. When we think of really great data analysts, when they're working on different projects and they're thinking of how much value can their insights bring, the value can only come from something happening. So usually the way we like to frame our insights is, how can people use those insights to drive some sort of action that will lead to more value? So there's this, if you think of this control, this data crisp DM thing, it all goes back to this business understanding and value too. Okay, so let's say now that you've done the insights and someone is doing something about that problem, maybe you want to report back on the changes. How much extra value did it add? How did it uplift the customer conversion, or different things like that? And usually for reporting, what we see is this usually lives in the realm of dashboards. So Tableau dashboards, Shiny dashboards, Power BI dashboards, whatever dashboards, you name it, probably that's where they're happening. A lot of the time for the reporting, there's also going to be a lot of data work as well. So if we go back to this crisp DM thing, you're going to be in a lot of this data preparation, and as well as this data understanding. Because often when you're doing the reporting, you need to be very clear on what each metric really means, and then how that should be prepared properly to make sure that the results are as correct as possible. So for reporting, it's going to be dashboards, but there's another underlying theme where it should be correct. So you really want to be as correct as possible. I was reading a post recently on LinkedIn, actually, that was saying, would you rather have an incorrect, or maybe not an incorrect, but it was like would you rather a like 50-50 dashboard now, or would you rather a perfect dashboard a little bit later? I think the general consensus on the post was to have like, we want the dashboard now, For me personally, I get very like jittery when people say, "Oh, we want the data now, even if it's not ready." I think it's a very common pitfall because data integrity and having the right insights and the right metrics and all of those things is so important for any of the data work. And I think as a practitioner, you really, for me, I like to take pride in my work, and I always want to give the correct thing. And if it's going to take a little bit longer to get the thing, I would try my best to try and negotiate with whoever the business stakeholder is, or whatever the party is, to actually let them know, look, I can give you the data now, but I have no idea if it's going to be correct. Are you okay with that? And then it will be up to them to really make the decision. But honestly, I would always love to have enough time to try and give them the right thing, because we see too often in industry, people make a lot of snap decisions off insights which are incorrect. And that's really not what you want to be doing with the data, especially now that we're getting more and more data. Everyone wants to be data driven. We really need to focus on getting the things right, probably at the cost of making it slower and having more certainty. But maybe that's just my own personal view as well. Okay. The next type of problem that we want to solve is where usually the data scientists and the machine learning engineers will live in, but it's this prediction space. So let's say you've done the insights, you've done the reporting, and now you've actually identified an area where you can actually utilize some machine learning to make a prediction of customer behavior, of forecasting certain metrics. Let me answer this question before, actually. So, Ogawa, thanks again for your question. Does the reporting happen before the solution is implemented, like trying to predict results, or after the implementation? Very good question. I think I put reporting here first because the reporting doesn't always need to happen after a machine learning. Oh, no, wait. Let me reword that. So machine learning doesn't always have to happen first before the reporting has to come in. Reporting can also be there for just your normal business reporting. Let's say sales metrics reporting or forecasts, maybe your campaign reporting that don't have any machine learning, and it's just if-else statements selecting different customer segments to target. This is where I'm coming at for some of these reporting projects. But when you do a machine learning project, I highly recommend that you definitely try to manage your own reporting for any machine learning initiative that you build as a machine learning practitioner or a data scientist. I've seen places where, let's say, the data scientists would build their models and run the experiments or whatever, and then they just throw the reporting over to another team to do. Honestly, I don't think that's the right approach, because as a data scientist, you're essentially designing the experiments that you're going to run. It only makes sense that you also report on them because they're your experiments. So I think as a machine learning practitioner or a data scientist, you really want to own as much of the process as possible. You don't want to give it away. You want to keep all that good stuff as much as possible, so then you can have real great understanding of how did my project go? How did my machine learning outputs actually impact the value in the business? So I highly recommend anyone who's working on their first machine learning projects at work really aim to go above and beyond and try and take as much ownership of everything as much as possible. It's only for your benefit, really. I think having a better understanding of where your outputs are being used, how much value it's going to drive. Of course, you can put it on your resume and it looks really nice, but just having that understanding and the business context of where it's being used is super important. And I really want people to focus on that. All of the machine learning techniques and the deep learning and the GPT-3 and all of those things are more they're just kind of tools to use to really generate the value. And if you're not able to translate the work that you've done to build the best model or predict whatever's going to happen to an actual value or business outcome, then you're really missing the point there. So I think people really need to expand their sights and view it more from like a business perspective. Within like all of the data science and machine learning, we're really trying to drive more value. I know that there's some purists out there that just want to build the models that perform better, like in a Kaggle competition where you're getting like a 0.005 increase in the AUC and you win the competition. That's really cool. But when we think of it in a practical sense and when we're using it in the industry, we want to be able to really understand where that uplift is coming from. If you build that model, which is slightly better, but you took an extra 10 days to build it, more often than not, the business will ask you, why did you spend an extra 10 days? We could have used the one that you built straight away and we started getting value for it. And then you can think about optimizing it further. So yeah, that takes me on to, so I think we talked about the prediction thing here, and that takes me on to the optimization type data projects. So when we think of optimization, we can almost think of it like that reinforcement learning problem. So when you think of, let's say for marketing, for example, marketing is a very common use case for this reinforcement or optimization problem, this thinking. So I'm going to zoom in here so I have a bit more space to draw. Okay, so let's imagine that you have certain customers who will receive various campaigns. And one of the things that people always love to build is something which is, usually they call it a decision engine or a next best customer, next best customer offer, or all these different names where they're trying to like almost automatically optimize which campaign you should send to a customer to optimize for a certain metric. Usually the metric is customer lifetime value, or maybe it's something to do with customer satisfaction. Maybe it's to do with sales or conversion, but usually the different levers, they will all try to optimize a certain thing. But when you think of the optimization, it's all about how do you drive the most value out of the system. So the system could be maybe you've got 10 different campaigns that you could possibly send to customers. You can use the historic data to try and not just predict which campaign we should send the customer, but it should kind of almost it will predict the sequence of campaigns that you could send. Which campaign should you send 1 versus 2 versus 3? Which channel should you send it in? Do you send it in SMS or email or Facebook? And all of these things, you can think of it as one big reinforcement learning problem almost, if you're smart enough to build out and design that process really well. So in the optimization problems, it's more around when we think of optimization, there has to be a feedback loop. So we sometimes have this within the prediction machine learning problems as well, but more often than not, they're usually separated out. So when we think of the optimization, there's always a feedback loop, and it's almost sequential in nature. So when we think of reinforcement learning as well, there's always this time axis that happens. So something happens, the agent that we're trying to train will have to make a decision of which action to choose. They make the action, then you look for the result based off that action, and it updates the loss function, and then you get the new data coming in, and then now you know, okay, if I've done action A and it gives me a reward of 0.5, maybe I don't try it again. Maybe I try action B to try and find out what the reward is. So in this sense, when we think of marketing, the reward could be whether a customer clicks on something based off what ad we sent them, or maybe it's based on the wording of an ad. So it can get very, very granular. But when we think of optimization projects, these are the two main themes, really. There's usually a feedback loop. There's actions and rewards and different things that you can observe. And more often than not, it's always sequential. So you'll optimize for time step 1, and then time step 2, you have new information coming in, and then you optimize the system again based off another metric, and you continue forward, and that's why you optimize the system over time. So Yeah, in my experience, these are the areas where machine learning and a lot of the data projects, so data engineering, machine learning engineering, data analytics within this insights and reporting, and within the prediction and the optimization is usually where the data scientists and the machine learning engineers will live. But yeah, I hope this gives you a better flavor of what types of projects that we work on. Okay, so I have a question here from Anne. Thank you very much for your question. So it's clear how data projects can differ. What are the main challenges for each type during deployment? Oh, that's a great question. Where do I start with this? Okay, so I think I'm going to use a different color pen just so I don't confuse myself. So the challenges for the foundational aspects, when you think of the pipelines and the data engineering, usually the environment will be the main challenge. So you can imagine a lot of the data engineering work is now moving on to the cloud. A lot of the challenges would be, are the downstream users comfortable using the data assets in a certain environment? Do we need to move data from one environment to another? Are there certain limitations on the networking? And more of the technical components of will the data be there? How does the data get processed? What's the robustness of the data? What do we do if the data is not there? Is it real time? Is it going to be streaming? How robust and future proof is this solution? So I think of the main challenges for the foundational data projects and the data assets is usually going to be the environment. The solution design will be very important as well. Now that we move more into the cloud, solution design will be more and more of a thing for machine learning engineers and data engineers. We'll really have to focus in on probably even multiple cloud infrastructure. So you might have, let's say you've got an AWS database interacting with a Google database, and then there's also an Azure database, and you all want to work within, or let's say bring it all back within a Google one. So yeah, there'll be more challenges once more work goes onto the cloud also. But I think, yeah, for foundational and deployment issues, most of the time will be environment and the solution design for the foundational data projects. When we think of the exploratory, I found in larger organizations, it's usually going to be access. So how do you get access to certain data sets? I know it sounds like a quite basic sort of thing. Like if you don't have access to the data, you can't really do anything. But sometimes these things take time in large organizations. So usually that's where it kind of gets blocked. There might also be political things as well, where maybe one certain silo doesn't want to share their data, so you have to kind of network your way through different things and different barriers to actually get your hands on the data. So it's more of like I'd say it's like a political thing before you even get to the deployment stage. Usually for exploratory data analysis, we don't really deploy anything in general, but usually the exploratory kind of lead into more foundational. They're more like a precursor type project. When we think of the insights and the reporting, most of the time the deployment will be, I think for these things, usually deployment is less of an issue. What we see as data analysts, they might schedule something on a server, and that's good enough. If they're running a Tableau dashboard, maybe they deploy it somewhere. I think as long as the infrastructure is in place, most of these things are relatively straightforward. So I would say probably infrastructure is the most important for deployment of insights and reporting. Maybe some integrations, which kind of lies within the infrastructure space as well, but integrations with the different data locations and the data assets that need to feed these insights and reporting is important too. Especially like all the connectors like the JDBC and the ODBC, or the different types of connectors that you actually use to query the data wherever it lives. You might need to make sure that they're working within the tools that are being used within the insights and the reporting. But apart from that, usually they're quite straightforward. There's not too much of an issue within there. When we think of deployments for prediction, machine learning algorithms, and the optimization, yeah, that's where most of the problem usually lives when we think of deployments. I think for deployments, it's usually the solution design will always be important. So I think having a really great grasp of the different technologies that are involved is always going to be key for the deployments of any machine learning and optimization project. Um, a lot of the problems that I've seen is usually where, let's say, the data scientists, they're working on their model and they're building away and hacking all these different things. Oftentimes, data scientists are not really aware of how the machine learning engineers or the data engineers will actually productionize their work. So it's more of like, let's call it a knowledge gap, where it's not really a knowledge gap in skills base, but it's more a knowledge gap of what the other parties do, what their actual roles are, and what sort of processes are actually being used to deploy something. So I highly recommend, usually for the data scientists that I work with, to upskill themselves more on just the knowledge of what the machine learning engineers are doing, what sort of technologies they're using. So then they can think through, okay, if I'm going to be building a model, should I be using certain technologies? Should I be processing my data using certain tools? Do I do everything in pandas, or do I do everything in SQL? Or what's easier to actually integrate? Do I need to put it into a Docker file and ship it as a Docker image? There are all these different things that tie in differently depending on the systems that the engineers want to use. So usually I think for really high functioning teams within the data space, so where you'd have like almost your BAs who understand the data, would be very in tune with your data analysts who will be doing all the insights and the reporting. Then you have the data scientists who will be very, very good with the machine learning algorithms, but they'll be able to get the data from the data analysts and the understanding from the business analysts. And then they'll be able to build models in a way which is very easy to flip into production by talking closely with the machine learning engineers and the data engineers who build those frameworks for machine learning and the pipelines for the data engineering. So yeah, I really think in future, what we'll see is there'll be leaders who have experience across all of these different streams, and they kind of group people and make sure that they're all working together. So what we're seeing now is it's quite rare to see people leaders with deep technical skills in all of these different areas. Hopefully, it will change in the future. More technical people hopefully will get promoted into leadership roles, and then they can kind of progress where the data projects really should be, so we can get maximum efficiency. But I think it'll take a little while. But I really hope that we can, at least for all the technical skills, we can really teach these to people, because in my experience, I've managed to learn them pretty much on the job without much formal training. You might have seen my post about no STEM degree and no master's and no PhD or whatever. But I think, in all honesty, I truly think that all the different tech skills, all the coding skills and the data analysis and all those sorts of different skills, literally, if you think through all of the problems logically and you work through it step by step, preferably with someone who's done it before, all of them make sense. There's no real, it's not rocket science, let's put it that way. You just need to understand that things will be challenging at the beginning. You go through the motions and keep working at it, and over time things will just start clicking. I think, a lot of people should have more self-belief in themselves. Okay. I'm going to go on to the last slide. So this was my way to kind of link what we've been talking about the project, the data project management, as well as some of those machine learning applications for in different industries, and then use that to try and formulate how you'd actually apply it to when you're looking for a job, or when you're trying to build your own portfolio projects. So then you can really hone in on what you want to demonstrate to a certain hiring manager. So I've just broken it down into steps here. I'm just going to drink another cup of water. Okay, so the way I wanted to break it down was essentially, first of all, choose a project type. So if you're applying for a data science role, and we go back to these project types, most of the data science will be focused within clearly this prediction space. And if you want to be more advanced and you want to be aiming at maybe potentially a machine learning engineering role as well, you might want to demonstrate that you have some ability to, well, maybe not to optimize, but you might be able to understand some of that solution design and some of the machine learning engineering knowledge to demonstrate that you understand some bits of the deployment process as well. So that's what I think of for the project type. It's where you have to think of it from the hiring manager's perspective and think, okay, what sort of role are they trying to fill? Like sometimes it's you won't know. So you should try and back yourself and just try and demonstrate as many skills as you can. So that's another approach as well. So if you really wanted to have, like, let's say you aimed for like a full end-to-end project where you do the whole thing, where you have like lots of different data sets, you try and build your own pipelines, you do some exploration, you look for some insights, maybe you do some reporting. Reporting is a little bit more difficult because there's no real change in what's going on, but you can still build dashboards and different things like that. Maybe then you build some sort of model, try and tie it back to a business problem. And then at the end, instead of doing the optimization, which is a little bit difficult as well, unless you have the right data, maybe you try and build out some sort of API that serves the model when someone hits like a GET request or something. So all of these things, it's more just being creative in how you can demonstrate some of these skills, but you should really just try and understand what sort of project you want to work on, what sort of skills you want to share and demonstrate, and then just go after it. So choosing a project type is pretty important. Then I think the next thing would be to try and find a data set that matches the project that you want to work on. So this one is where it takes a little bit more time. So especially if you're a new starter within your data journey, it'll be very difficult to actually identify which data sets you can use for certain problems. So I think good places to look for data sets will be your traditional, let's say, Kaggle. There's tons of different open data sets you can probably, like, if you Google like open data sets, I think there's stuff on Reddit as well. Like if you just Google that, you might find a few. There's a few on BigQuery. So from Google, there's some open source stuff as well, but you need like a GCP account to actually make that happen. But yeah, I think once you figure out like what project you want to work on, then you should try and find a data set. I think people often, when they do their coding projects, they start with a data set and then they think, okay, what am I going to do with it? And you try and shoehorn the data into a certain project type. That can work as well, but I think you need more of just as long as you are focusing at it from what am I showing to the hiring manager, what value am I demonstrating that I can bring, that's fine. And all of these steps in terms of exploring the data set and figuring out what problems you're going to actually solve. So the next step will be design a business problem. They all have to be tied back to value. So I think this is the most important thing. If I'd have to almost like pin down this whole chat for today, it's if we're going to do anything with machine learning or data mining or data visualization or dashboards or anything, we really need to think about the value. So let's say we're working for a business, we build the model. What value is the model going to bring? Another example, let's say we build a dashboard that demonstrates some key metrics. What value is it going to bring? What sort of actions might someone take if they see a certain metric go down in a month or something? So this is where the value usually comes hand in hand in creativity. It's how you can think about certain problems and think from the perspective of someone else or another party, and not just think of it as purely analytical. Oh, I'm going to build a visualization with seaborne for a correlation heat map, and that's it. So I think I know it's really cool to build some of those things, and it's very fulfilling to actually get a lot of those skills on your toolkit and your tool belt to say, oh, I've done this before, but really focus in on the value that it's bringing. I think if you really focus on that, that will really give you like almost like a 180. So if you've been doing a lot of projects and you've been demonstrating, oh, I can do clustering algorithm and PCAs and all these different algorithms, and you just kind of you run through all the different algorithms that you can implement, but you can't tie it to how it's going to be used in a certain business problem. That's the gap. I think the more you focus on that gap of translation of what you're doing to how the business or how like what sort of value that it's bringing to a potential business, I think that's where the gold is, and more focus really needs to be spent on that. But yeah, once you have your data set, you design a problem that you're trying to solve with the data. So it demands a little bit of creativity, a bit more creative thinking, especially. Then you would go ahead, you create a plan, just like in a normal project. Like let's say you were working in a data set where all of this happens. You would create a plan, try and make timelines for everything, because of course you're going to be doing this in your spare time if you're still working. You need to really make the plan achievable, and don't set your expectations too high as well, but of course work hard too. And then pretty much you want to do the plan, make the thing, evaluate your project. So I know this is a little bit more difficult, but I'm trying to run up some of the stuff on the Data with Danny community, where I'm very happy to help you guys with some of the problems. I've shared one of the end-to-end marketing problems that I've worked on as well. I made it a little bit more funny with some bribes and BTC and all this different things, so it might be a bit more interesting. But yeah, I think part of doing these coding projects is really cool if you're doing all these projects, but even cooler if you get people to review what you're doing to make sure that you're on the right path, to try and identify the gaps where you can improve. If let's say your version control or some of your Git behaviors are not as good as they could be, someone can kind of give you some guidance. The problem is, like, how do you find people to give you that feedback? So I'm trying my best here to try and open up some sort of Slack community so people can just kind of ask questions wherever they can. But yeah, I think for me throughout my career, the most valuable thing was not in getting the learnings from people when they were just talking at me and explaining concepts and all of that sort of stuff. It was more, I got the most out of my learnings when I actually tried to build something or tried to code up something or understand something. And I was vulnerable enough to actually just share with people, oh, look, here's what I've done. Let me know where I can improve. What have I done wrong? Could I have done this better? And I think people with that sort of growth mindset, they're very, very, usually they're very cool to hang out with. Not that I don't think that I'm that cool that people try and hang out with me for no reason, but I think it's people just enjoy others who are always looking to grow and improve their skills. I think it's very inspiring. So yeah, try and find a group of people or others, like other peers, other people who are on the same journey and are learning the same things, and try and like build a study group almost like we had in university, where you really want to share as much as you have. I know I talked a lot about this on in previous videos where I say you're working on a project, you should try and work on the project with the aim of teaching someone through a blog post or through a GitHub, like a whole project where someone can take a look through what you've done, and hopefully you can actually share some of your learnings and help them in their problem area. So I think it's like a very virtuous cycle of good as well. So definitely something to look into too. And that's probably where it ties into with this share the final results. Okay. I think that's it for the material for today. I'm going to go through a few more Q&A because there's a few more bits here. I'm going to switch back to my face. I hope you guys had I hope that was useful, insightful. I don't know, you can feel free to give me any feedback directly in the comments here, or hit me up on the Slack or LinkedIn. I'm always looking to improve these live streams. I actually have a lot of fun just talking with you guys and trying to help you guys with some of the questions that you ask, as well as me just sharing some of the ideas that are in my head that I want to talk through, that I think are quite helpful. So yeah, I'm just going to go through a few more questions too. So, all right. Vipul's question. Do you suggest all the skills required for deployment of projects should be worked upon before you start working as a data scientist, or learn them on the go when you're working? Okay, so this is a challenging question because what we see is it's really hard. So one, it's really hard to actually land a data science role in this current environment. There's a lot of competition, COVID related stuff. There's not many roles hiring. So they want people with the right skills straight away. There's less companies who are looking to invest in people in that sense and take a bet on you. But on the other hand, a lot of us, like including me, for example, I learned a lot of my skills on the job. So I consider myself almost one of the very, very lucky ones, where I had really great mentors. I worked on interesting problems and I worked with big data sets. So I'm one of the really lucky ones. I think I'm really blessed. But for a lot of people trying to break into new roles now, it's really difficult. And I really feel for you guys. Like I'm trying to figure out what's the best way to actually help people develop some of those skills. And I think projects are probably the best way to do it. I really think a lot of the skills, they're not difficult to learn if you have someone who's done it before and can guide you and give you feedback on what you're doing to improve you. But I think I'm still trying to figure out what's the best scalable way to actually do that, so I can I'd love to do that full time. And if someone were to pay me to do that, I would just dedicate like as much of my life as possible to try and train as many data scientists and machine learning engineers and data analysts or whatever to really just focus in on this space, where people always say like, oh, there's such a shortage of data professionals in this space, but it doesn't seem like too many people are actively working on trying to bridge the gap of that shortage. So I'd love to be known as a person who's trying to do that with their like their career or their life. But yeah, I think you don't need to learn everything. I would say if you know what roles, or if you know the roles that you're applying for and you know what they're looking for, like you'd have to network in or try and talk to people who are working in that company, or maybe in that job description they tell you, oh, we need people who know R, Python, good with ggplot, good with pandas or whatever. So then you can demonstrate all of those skills in a certain project. It'll always be difficult to try and find end-to-end projects anywhere. Like I haven't seen any courses that go through a really strategic level project and kind of break it down and get you to like write your code really well. Your code has to be in production quality. Then you deploy it into some service. Then you present it to the business or whatever. Like I think it's a big ask. I think I'm personally trying to work on something on the side to see if I can fill that gap, to try and almost provide you guys with like as close to real life projects as possible, and almost pitch it as like a mini internship where we'd be working together, for example, and I would share you some data, give you some context on what the business problem is that we were talking about. And then you guys would work together and keep asking questions and trying to formulate your plan as though we were working. Because I think the work experience component is super important. And it's just a shame that there's not many companies are looking to provide more of that internship style training for a lot of people, purely because there's a lack of funding or lack of appetite from the business to actually rely on people with less experience. Like it's a bit annoying, to be honest. All right. Sorry, I might have went too deep into that, but it's something that I'm quite passionate about. I think, yeah, everyone deserves to have the chance to learn the stuff that's going to be really useful. And I think Yeah. Okay, cool. So Pete is asking, what is the average lifespan of a machine learning project? Traditional projects live up to a decade. Yes, this is correct. I asked this because of the speed with which data changes. Yeah, so it really depends on the environment that the machine learning project is happening in. So if it's, let's say it's like a tech company where it's very forward thinking, very fast, all the infrastructure is on the cloud, everything is like CI/CD, continuous integration, continuous development. Machine learning projects could actually still have a long lifespan, but it might just have lots of multiple iterations. So you launch with an MVP, which is like a very basic model. Maybe the next stage you start adding new features, more data points get added in. Maybe in the third stage, you start getting some of the results based off the first two stages and you can optimize it a little bit. Maybe in the fifth stage, you start using deep learning or whatever it is. So I think that's more of the cadence that we want to see in machine learning projects moving forward, where you would almost go to production straight away, ideally, right? So you go to production straight away. It doesn't matter if it's the best thing or if it's not. It's probably ideal if it's not. And then you kind of keep working on it and keep improving it. But the cadence of which you deploy into production and start using the outputs is almost instantaneous. So there'll be a lot more focus on pipelines, on software engineering, on having really good, solid coding quality. So then when you make the changes, you know exactly what's being changed, what impact it has, whether it's going to break your existing code. All of these things are very common in a software development space, but within the machine learning and the data science space, it's less so prevalent. And I think that's where we should be focusing more on, because as we move more and more towards the future of where the machine learning and the data science is going to happen, more of it will be automated in that technical sense, where a lot of the changes you won't have to go through multiple rounds. So machine learning projects will either be very, very quick because you can just flip it into production and then you leave it until it breaks. Maybe there's automation on if the model starts having poor performance, it will just retrain the model. But yeah, ideally, I think you'd want multiple iterations of models to try and continue improving on it, as long as the business sees value in the improvements as well. So yeah, I don't think there was a clear answer to your question, but yeah, I really think having the technical skills, like some of more of the raw development skills, will be very valuable for data scientists moving into the future as well. Okay. Next question. All right. Oh, I've skipped a few. Actually, no. Okay, yeah, I think I've covered most of the questions for today. I know. Sorry, this has been another long stream. I surprise myself each week by how long I can actually talk to myself, which is pretty funny. But yeah, I'm really, really thankful to have you guys with me tonight. Yeah, I'm just really grateful that I can help and just share some of my experience. And I hope you guys get a lot of value out of what I'm doing. And yeah, please feel free to join my Slack channel. I think I've got a link below this live, so there should be a description to sign up for Data with Danny. Yeah, connect with me on LinkedIn, like and subscribe this video, subscribe to my channel, do whatever you need to do. You can join the Slack and DM me directly if you have any feedback or questions or anything that I've missed in this live that you want a bit more clarification on. More than happy to help you guys out. If you're interested in more of that internship style project-based learning, it's something that I'm really passionate about. I'd love to focus more time on. Yeah, please let me know on any of those channels as well, and I can definitely share with you what I've been working on and some of the other thoughts that I've got. I'd love to get your feedback on some of it as well, because I'd love to figure out a way where I can actually do this full time and make it viable for me to just kind of move off some of the other work and just focus on helping as many people as possible. So yeah, that would be really awesome if you guys could help me out with that one. But yeah,
That is pretty much it for today. Thank you again so much for joining me, and I hope you guys enjoy the rest of your Sunday. Thank you again. Peace out.